Hello, future doctors. So I hope you are doing well. Here we are going to have a look at the solutions for electrostats part in your NEET test 2. Some of a very challenging questions from a NEET level is in the paper. So make sure you understand every funda associated with a question. We shall have a look at the 91st question. The 91st question deals with the concept of closest distance of approach. Well, there isn't any direct formula to crack the question. You should understand what is happening, the physics of the question. The scene is as follows. There is a positive charge Q and one more positive charge Q. Both are placed on a smooth, frictionless floor. This is another way of saying that if I take both of them together as a system, if I take both of them together as a system, I envelop them with a boundary. There is no external force. Of course, I mean horizontal force acting on the system, which means because there is no friction, right? So there is no external horizontal force. Whatever counts is only the internal force. So from this fact, I can deduce one important conclusion. The conclusion is the momentum is conserved. Whenever the net external force is zero, then momentum of the system is always conserved. Initially, both of them were at rest, right? So both of them, no, one is at rest. The question says one is at rest, other is projected with the speed of v. So the initial momentum of the system is m into v, where m is the mass of the charge, and both are identical particles. So the mass of this charge is also m, this charge is also m. Charge is also identical, q and q each. So final momentum should also be the same. What expression can I write for final momentum? Well, in the final momentum case, since they are approaching closest, which means one time it will happen that the two charges, please remember that the charges are like. So this charge on the left is going to repel this charge on the right, and this will start to move towards right. And this charge on the right is going to repel this charge on the left. So this is going to eventually slow down, whereas this is going to eventually speed up. This is going to slow down, this is going to speed up. There will come a time where the distance between them goes to a minimum. That is the closest distance of approach, CDA for short. Let that distance be R. At that instant, the concept is both of them will have the same velocity. Let me call a velocity as V dash. You may ask, why should they have the same velocity? Well, if they had different velocities, then the distance between them would go even, further. This ball would go even closer to this ball because both of them are moving with different velocities. If they move at the same velocities, then both of them will appear to be at rest with respect to each other. This ball is going to be in a state of rest with respect to this ball, which means the distance between them is not going to reduce further. Okay. So wherever you find closest distance of approach, the hint is at that moment when the distance is the closest, both of them will have the same velocities. Let that velocities be v dash and v dash respectively. So what is going to be the final momentum? Since both of them have the same mass, final momentum shall be 2mv dash. I'm equating the initial and final momentum since momentum is conserved. So I have mv equal to 2mv dash. That cancels m's on both sides and it gives me v dash equal to v by 2. Yes, good enough. But I have nowhere come closer to find the closest distance of approach. Now, how to get R into the whole question, whole scope of the things? To get R, we use another conservation principle. Remember, R is involved only in one of the equations in electrostats, that is potential energy, U equal to K Q1 Q2 by R. See, there's an R. So the hint is I need to bring in potential energy somewhere. If I have to bring in potential energy somewhere, that means I need to use energy conservation. So the second golden concept after momentum conservation is energy conservation. The energy of the system initial energy of the system is only the kinetic energy. Why? Because initially this charge had a velocity of v going towards the right, and the distance between the two charges initially is too much. It is very large distance, so I can ignore the initial potential energy and consider only the initial kinetic energy. Therefore, initial energy of the system is simply half mv square. What is going to be the final energy? Final energy is both of them having same speeds, so they will have the same kinetic energies, as well as the distance between them is r, the closest distance of approach. So they are going to have potential energy, which is kq square by r, plus they are going to have kinetic energies, which is half mv dash square plus half mv dash square. Right. So initial energy is half mv square. Final energy is kq square by r plus half mv dash square plus half mv dash square. I equate the initial and the final energy. But you have only one thing missing here. V dash is an unneeded variable. I can put V dash as V by 2 in both of these expressions, and I will have R exclusively as a function of only V and Q and nothing else. So there you have the answer. You put in the terms and you will get the answer. So anywhere you get the closest distance of approach once on a very simple level, you can look at it as two conservation laws. One is momentum conservation, another is energy conservation. Energy is conserved because there is no friction. Momentum is also conserved because there is no friction. So here the absence of friction is enabling you to say that both momentum and energy is conserved. Initial energy was purely kinetic. Final energy is a mixture of kinetic and potential. So that is the concept of CDA, where at the moment of closest distance of approach, both masses will have the same velocities. That is one of the key concepts. So that is 91st. Well, you may also note this in NEET exam, it will help you a lot. B, C, and D are similar choices. High chances are that 99% chances are that the examiner would have picked one of these similar choices as a right choice. So if you see one option being entirely different from the others, please eliminate that option. That option is not the correct one. Here, q square by mv square, q square by mv square, q square by mv square, but here it is q square by mv, different. So it is not the right answer. The right answer is between B, C, and D. Can we do any further elimination? We can't do further elimination. Reason being, all BCD options are alike except the numerical part. Here it is 4, here it is 2, here it is 3. Okay. So we can't use elimination satisfactorily. It is we need to go do it the rigorous way. You can either attempt this in the first for the first time, or you can revisit it after you attempt the other questions. But the concept is this: momentum conservation, energy conservation. The whole assumption is based on no external force because there is no friction. Both of them are placed in on a smooth flow. That was question 91, quite a conceptual one. Question number 92. We have a regular polygon, regular, which means all sides are same, of n sides. They're asking what the ratio of V by E. Okay. So here is where we try to be slightly, smarter than the examiner. Here is where I put n value as 3. I assume the value of n to be 3. Sir, what is what will happen if I assume n is 3? Well, if you assume n is 3, this is for the second question or the 92nd question. If I assume n is 3, I will have a regular equilateral triangle. And the charges are placed at two vertices, not the third one, right? And I just need to find what is the field here. I need to find what is the potential here, and that's it. Then I can find the ratio. Well, what is the field at the center O due to these two charges placed in equilateral triangle? Here I exploit symmetry. If I place an imaginary charge of the same polarity, identical charge at the third vertex, the total field at O is going to be zero. That's a very well known result. Due to symmetry in a regular polygon, the total field at its center will always be zero if charges are kept at all the vertices. So EQ plus EQ plus electric field due to the red charge Q is always going to give you zero. But in our question, I need only the sum of electric field due to these two Qs, not this, right? So what do? I need the sum of these. So I take this term to the other side. I have electric field minus EQ. Here I need the much needed sum, total sum resultant. And what is given? It is given that the distance of each corner from the center is R. So what is electric field due to the red charge at the point O? Due to the red charge at the point O, it is KQ by simply this distance is R square. So the sum of electric fields, what I needed in the question, I placed this charge imaginary. So that is something which I did to simplify it. But originally I needed field due to this Q and this Q. That turns out to be KQ by R square in magnitude. So the electric field at the center O is KQ by R square. What about the potential? Wow, potential is very easy to calculate. Principle of superposition here. The total potential at O is due to this charge Q and this charge Q. That would be KQ by R plus KQ by R. Totally, it is going to be 2 KQ by R. I need now the ratio of V by E. V by E is going to be, if you do the arithmetic, it's just 2 KQ by R by KQ by R square, right? So KQ and KQ gets cancelled. It is 2 by R by 1 by R square. So it is going to be simply 2 by R. Good, cool enough. But uh, how does it help? I got to know V by E is 2 by R for what? For the configuration shown or n equal to 3. So if I substitute n is equal to 3 in the options, I need to get as 2 by R. The option should be 2 by R. If I put n equal to 3 in the options, the only option which gives me 2 by R is option C. So C should be the right choice for 92. Here is where you make very difficult things easy by assuming the value of a variable as something which you know. Here n is 3 because it becomes an equilateral triangle. Now going on to the 93rd question, slightly a thinking based question. Here we have a circle. Now I carefully place all the odd numbers. Here I place the first charge, then I place the third charge, then I place the fifth charge, then I place the seventh charge, so on, right? Then in between, I place the second charge. Here I have the fourth charge in between. All right. So what we are going to do is, so we actually do this placing the charges in the different shades as the second charge is between the first and the third, the fourth charge is between the third and the fifth, and here also we place a sixth charge. So there are all odd charges and even charges, right? And placed in this fashion. They're asking what is the total potential at the center. This is the center O, potential at the center O, and field at the center O. Well, Potential is a vector quantity. Potential is a scalar quantity. So it is just a number. My bad. It is just a number. So there are equal number of positive charges as there are negative charges. So if I add them all up, K by R times summation of Q. Why did I take K by R? Because all charges are equidistant from the center, right? So I can just take A by R out. If I sum all the charges, they have same magnitude, opposite polarity, I will get potential as 0. So which of the options has potential as 0? Only B and C. I can eliminate A and D, right? Between B and C, what might be probable? I will just take this seventh charge and the first charge. Due to the seventh charge, the field at the center is pointing towards the center. Similarly, due to the first charge, it is towards the center. Both charges have the same polarity. Arrows will definitely cancel. Therefore, the electric field contribution is 0 from the first and the seventh charge. But look at the B option. In the B option, there is a 10 beside the charge Q. There are 10 charges, I agree, but I have already found out that the first and the seventh charge contribution is not there because electric fields have cancelled. So B cannot be right. The only alternative is C. Both potential and field is 0. So here is where we take the help of options and make our lives more easier. Now going to question number 94. You see, in question 94, this is a very familiar and a very frequently tested concept from a NEET perspective, where the charges are connected by a conducting wire. So henceforth, where this is for question number 94. So henceforth, whenever you see charges connected or the shells connected by a wire, immediate picture is after connection, both will have the same, both spheres will have the same potential. Both spheres will have the same potential. Well, if both spheres have the same potential, what is it in for me? Because I need the, if you look at the question, I need the charges. What are the final charges on both spheres? It is S1 and S2, right? So how can I get the final charge on them? Initially, S1 had some charge, S2 had some charge. After connecting, definitely charges will flow from one to another till both of them have the same potential. What to do? How to approach this now? Easy. Whenever you have this case, you go for Q equal to CV, where C is for a spherical capacitor 4 pi epsilon naught R. Well, how? What next then? Look, both of them have same V. Both of them have same potential. Whichever of them has a higher capacitance, that will have a higher final charge. Which of them will have a higher capacitance? I know capacitance depends on 4 pi epsilon naught R. Whichever has higher radius, that will have higher capacitance and that will have a higher charge. Yes. So now is the time to look at the options. Whichever has a higher radius, that means sphere 1 has higher radius, that will have a higher charge. First one option is eliminated because it shows both of them have same charge. That can't happen because both of them have different radius. Second one shows one has 4.5, other has minus 4.5. Utter nonsense. Since the total charge 4.5 minus 4.5 gives you 0, whereas initially the total charge is 12 and minus 3, which is 9. The total comes out to be 9. Here total comes out to be 0. It is violating charge conservation. Charge is not going out anywhere. It is simply getting redistributed. Therefore, B choice is also gone. Between C and D, whichever has a greater radius, that one will have a greater charge. So S1 should have a greater charge. That means this is also gone since first one has a lesser charge than the second. So right option should be option D, 6 and 3. Taking the help of the options and the help of the capacitance concept to crack the question. Now going on to question number 95. Here also, your understanding on a potential due to a dipole is being tested. How to crack this? Well, this is question number 95. I'll briefly highlight the approach. Question number 95. There is one dipole, there are two dipoles, each of them oriented like this, minus I cap, right? Now, the distance between them is R. At what point? Let us say at what, let's say at point P, at a distance of X from this, at what point is the potential due to both dipoles the same? How to go about this? We know potential due to a dipole is Kp cos theta by r square, where r is the distance from the dipole. Okay. But cos theta term is same for both dipole 1 and dipole 2 since the orientation of the both dipoles is same. So this point is located at theta equal to 180 degrees from both the dipoles. So cos theta term is same for both of them. So what matters? What matters is simply this term Kp by r square. For potential of the dipole 1 and 2 at the point P to be same, I need Kp1 by R1 square should be equal to Kp2 by R2 square. K gets cancelled. Just substitute the magnitudes of P1 and P2 given in the question. R1, potential due to dipole 1 at point P, distance between dipole 1 and point P, R1 is R plus X. Distance between point 2 and P, R2 is simply X, right? You put R1 as R plus X, R2 as X in the equations, you'll get a quadratic equation. Don't solve the quadratic because I can easily simplify this as R2 square by R1 square is simply P2 by P1. Don't solve the quadratic equation, instead take the root here only. R2 by, it will become R2 by R1 is equal to square root of P2 by P1. Instead of dealing with a quadratic equation, you will deal with a linear equation, which saves a lot of time and effort. So this is the approach for 95th question. Potential due to both dipoles at point P is the same. That is question number 95. Now question number 96. Trigger words. Final speeds given from rest through the same potential difference. Straight away apply energy conservation. The final kinetic energy is equal to the loss of potential energy. Potential energy is given by Q times potential difference. Q is a charge, V is a potential difference. Charge on hydrogen ion is the same as charge on a singly ionized helium atom. Singly ionized, so charge on helium atom is +1. Hydrogen ion is all obviously +1. So Q is same for both cases. V is also same. So what it means is kinetic energy of hydrogen ion is the same as kinetic energy of, say, helium ion. Hold on. If kinetic energies of both of them is same, we know that mass of a hydrogen ion is very less compared to mass of a helium ion. Mass of hydrogen ion, if I take it as 1 unit, mass of a helium ion, it will be 4 units, right? So mass of hydrogen ion is lesser than mass of helium ion. To compensate, speed of hydrogen ion should be very much greater than speed of helium ion. Both of them have same kinetic energy, but mass of hydrogen ion is less. So I can say speed of hydrogen ion should be greater than speed of helium ion. They're asking ratio of speed of hydrogen and helium. Therefore, the ratio should be greater than 1. So I can say A is eliminated, D is eliminated as a ratio is lesser than 1. Ratio should be actually be greater than 1 because I have proved that speed of hydrogen ion is greater than speed of helium ion. Between B and D, B and C, well, I can see 10:7, it seems. I can neither see 10 nor see this other, 10 and 7 doesn't come in this equation at all. It is 1 and 4. 10 and 7 isn't coming, so I can eliminate that. So the only left choice is option C for 96th one. So 96th one goes with C, right? These are heavy conceptual questions. Now, question number 97. This needn't, this doesn't have much working. Why? Because it is a NCRT example question we have done in the class as well. How to proceed with this? Well, we have two particles here, one proton and one electron. They fall through the same distance h and h. They're asking the time of like, will electron take the TE is electron time, TP is proton time. Will proton take more time to fall through H, or electron take more time to fall through H? Well, uh, here both of them are subjected to same field, right? So what is the link? From the knowledge of the fields, I need to get something which will help me in getting times. The only thing that can help me is acceleration. We know that acceleration is QE by M. Both electron and proton have the same charge. Both of them are kept in the same field. So what can I say about their accelerations? I can say acceleration of electron, since mass of electron is less, acceleration of electron is greater than acceleration of a proton. When? When kept in the same field. So electron is accelerating rapidly, electron is accelerating rapidly, whereas proton is accelerating slowly. So which will take more time? Proton is going to take more time since its acceleration is less. It will reach slowly, whereas electron is going to take top. It is just going to drop instantaneously. So electron is going to take less time than the proton. Well, look at the options. Time of fall of electrons should definitely be smaller. It can't be equal. It can't be greater. So right option is 97 goes with A. Here, there is no need of calculations much, just common sense. To drop through the same distance, the time taken will be dependent on acceleration. Lesser the acceleration, greater is the time. Greater is the acceleration, lesser is the time. That is how you can solve 97 very easily. A proton will fall slowly because it has more mass. Electron will fall very fast because it has less. To cover the same distance, acceleration matters. If you want to have a mathematical basis for this, you can use h is equal to ut plus half at square. Both of them are falling from brush, so u is 0. H I can tell is equal to half at square. See, h is same for both of them. So at square has to be same for both of them. So if acceleration of electron is less, right, at square has to be same for both of them. If acceleration of proton is less, then time taken for proton should be more. At square is a constant for both of them. This is a mathematical basis of solving 97th question. Well, now let us go to the 98th question, a tricky one. Concentric spherical shells having sigmas as their surface charge density. Radii is A, B, C. A is inside, B is outside A, and outside B lies C. And they have given a condition for relating all the three radii, C equal to A plus B. Then they want you to, based on this, they want you to relate VA, VB, and VC. How to do this? All right. So here is the approach for the 98th question. For the 98th question, here is the approach. One shell having radius A, another shell having radius B. Outside these two, there is a shell C. Radius of the inner one is A. It has a surface charge density sigma. Radius of the outer one is B. It has a surface charge density of minus sigma. Now the radius of this is C, and the surface charge density of this is again sigma. Sigma minus sigma and sigma, if I'm not wrong. Yes. So this is what it is. Okay, so I will just color code this to red itself to avoid confusion. Now, what the inner sphere is labeled A. Inner sphere is labeled A. Outer sphere, this one is labeled B. This is C. Potential at A, potential at the sphere A is KQA by A. Okay, for all the points on the surface of the inner sphere, I can take the inner sphere to be a point charge located at the center. So it is K charge on A by distance. Plus, it is also having a potential due to the charge on C, right? But we remember something. Inside a shell, inside any shell, field is zero. If the field is zero, then potential has to be constant. So at A due to B, the potential is going to be KQB by B, where B is the radius of it. So what about due to C? You got it right. It should be KQC by C. This is the potential at A. Now, how to do the same for potential at B? At B, B will have potential due to A, its own shell, and C. Due to A, potential at B is KQA by distance between the center and this is B. So it is going to be KQA by B plus. What is the potential due to the sphere B only? Shell B only. It is going to be KQB by B. What about C? It is going to be KQC by C. That is VB. Now what about VC? VC. VC, if you got the pattern, it's going to be KQA by C plus KQB by C, right? And then it is going to be KQC by C. Why? Because the potential at C, what is the distance of the center of the second shell and the outer shell? It is C. So we have KQB by C plus KQC by C. This is VA, VB, VC. But you may ask, sir, we don't know anything about QA, QB, QC. That is where potential concepts, that is where charge density concepts come in. I can say that QA by surface area of the inner sphere 4 pi a square is sigma. QB by 4 pi b square is minus sigma. And QC by 4 pi c square is again plus sigma. So this is about it. Surface charge densities is nothing but charge by surface area. So I can substitute QA as sigma into 4 pi a square in this equation, QB as sigma minus sigma into 4 pi b square in this equation, QC as sigma into 4 pi c square in this equation. You will get some expression involving A, B, and C. Later on, you use the condition C equal to A plus B in each of these above expressions for the potential. Pretty long question cannot be done within a time limit for a NEET aspirant, but you need to know the concepts. So this is a potential due to potential at a shell is due to three things. Potential due to its own shell, potential due to the neighboring shell and the neighboring shell. So totally there are three contributions for every shell's potential. Okay. If the if the sphere is inside the other sphere, potential due to this big sphere at this sphere is simply going to be K, whatever charge is there on this, by the distance between the center of that sphere to the outer one, that is C. That is something which needs further understanding and help. That's the most difficult bit. We are using superposition principle and knowledge of charge densities. That one is question number 90. Now, question number 99. It's a huge relief, okay? Because they're asking work done, charge given, distance given, electric field ka direction is given, work done given. Okay, what relates work done to charge, electric field, distance? Q into E will give force. I have got distance. Huh. So I can relate it as work done is equal to Fs cos theta, where F is nothing but QE. Q is given as zero point 0.2. E is what we have to find out. Distance S is 2 meters. And what is the angle between the force and the displacement? Because force is acting in the x direction, given electric field is in x direction. Displacement is going in a line, this making an angle of 60 degrees. So theta is 60. So cos 60 is 1 by 2. SC is 2, force is QE, work done is 4 joules. The only unknown is E, get the value of E. Work done is Fs cos theta. Why are we not using anything with potential here? Well, a potential you can use only when, usually when there are more charges than one. Here there is only one charge. So there's no use of doing potential kind of thing. So it is only work done is equal to Fs cos theta. That is question number 99. Question number 100. Question number 100 is also directly formula based. The fact is we use a formula E equal to minus dou V by dou xi plus minus dou V by dou yj plus minus dou V by dou zk. Relation between electric field and potential, because they have given potential, they're asking you to find electric field. Partial derivative to the rescue. If I want to find dou v by dou x, I will treat only x as a variable, y and z will be constants. So dou v by dou x in this situation is going to be simply 6y. So minus 6y I cap. Hold on. Minus 6y I cap. The value of y is 1. So if I put 1 over here, I'm going to get minus 6 I cap. Which of the options has minus 6 I cap? A and C doesn't have, so it is either between B and D. What is the next one? Minus dou V by dou Y. So Y is a variable and X and Z are constant. So the answer for this would be minus of, well, 6x minus 1 plus 2y. 6x minus 1 plus 2y, because y is a variable, x and z is a constant. 2z, x and z are constant. Now put z as 0, so this gone. X is 1, so I get 6 minus 1 as, you know, uh, 5. So there should be a 5 in the j cap direction. Between B and D, 5 is there only in the D, so D should be right. Okay, 1 1 comma 0. So 5 is there only in the D option. We don't work Z at all because it would be a time waste. So using the options and the concept of electric field is a partial derivative of potential, we can solve the 100th question. Now question number 101. In question number 101, we have two spheres, one small, other big. They are telling the total charge on the system is 0, which means if the charge here, the red charge is Q1 and the surface charge dense hollow sphere, right? Charge on the surface, the green charge is Q2. I need to have Q1 cancelling with Q2. In other words, the magnitude of Q1 should be equal to magnitude of Q2. Then only they cancel each other. But do I need all this to calculate? And there's a printing mistake. It is a ratio of R2 by R1. Ratio of R2, radius of the second, to R1, radius of the first. Do I need all this? Um, well, that is, you know, uh, something which we have to see now. Okay. So the what is Q1? What is they have told that both of them cancel because total charge on the system is zero. I know charge on the inner one should be equal to charge on the outer one. How do I get charge on the inner one? It is variable charge density. NCRT concept, charge on the inner sphere with a variable charge density is simply going to be integral 0 to R1, 0 to R1, because inner sphere is between 0 to R1. Rho is given as rho naught by R into 4 pi r square dr. I have already given you the standard configurations. So for a spherical element, this is going to be it dv. Rho dv. dv is always 4 pi r square dr. And what is Q2, charge on the outer one? See, charge on the outer one is a constant, sigma. It is not varying with surface. So charge on the outer one is sigma into surface area of the outer sphere, which is 4 pi r2 square. Well, that's about it. Now 4 pi over here gets cancelled with 4 pi over there. And you have, and r over here gets cancelled with one of the r square over there. So it becomes r integral of 0 to r1 rho naught rdr is equal to sigma times r2 square. That's it. That is, now the question is solved. You see, if you know basics, you can see that if I evaluate this integral using the golden rule, r square by 2 comes around. So both sides, this side it will be r1 square, this is going to be r2 square. But I need a ratio of r2 by r1. I need to take a square root. So whatever happens in the options, there should be a square root. Rho naught is going to be in the denominator since I need R2 by R1. In which of the options is rho naught in the denominator and there is square root? Rho naught in the numerator and there is square root, right? You see, I need R2 by R1. Here I get R1 cutting. If I take R1 there, sigma will come to denominator. Rho naught will stay in the numerator. I take the square roots. I need rho naught in the numerator and a square root. The only option that satisfies it is 101C. So the right option for 101 is C. So what counted here? Well, what counted here was they wanted to test whether you're comfortable with the concept of charge distribution. If the charge distribution is non-uniform, we use integration. If the charge distribution is uniform, we don't give a damn. We simply multiply surface charge density with the area directly, just like we have done here. If it is not, just like this one, then we need to, use integration. That is question number 101 for you. Well, question number 102. Ah, we need angular frequency of oscillation of an electric dipole. Once upon a time, this was included in NCRT. Well, by using the strategy which we had discussed some time back, all options have 1 by 2, 1 by 2, except B option. B is odd man out. So B cannot be the right choice. Examiner will give most likely the right choice between A, C, and D. Now, how to go with this? Let us find it. Let's use logic. If we know that torque is given as PE sine theta, isn't it? So if PE is more, product of P and E is more, then torque acting on the dipole will be more. If torque acting on a dipole is more, then the time taken by the dipole to come back to some position will be less. If torque is more, time will be less. If time is less, they have asked frequency. Frequency. Frequency is going to be more. Get the relation. Torque is P sine theta. If PE is more, torque will be more. If torque is more, time period will be less. If time period is less, frequency is more. Look at all the options A, C, and D. Where do you think the combination of PE is such that if PE increases, frequency increases? Obviously, option A. If PE increases, frequency increases. So that is the right option, option A. Why? Because I got to know that frequency is proportional to PE. So 102 goes with A. Now we will go for 104. In 104, we need the potential at point P. Again, whenever you have three sheets, even in CBSE, it is standard question. Sheets, we use principle of superposition. Okay, look carefully. Due to the minus 2 sigma, charge, the field or the charge density, field at P is going to be downwards because field is always going to point towards a negative charge. Due to sigma, it is going to again be down because the field always points away from a positive charge. Due to this minus sigma again, it is going to be at point P, right? It is going to be down. So as you see, all the three fields are in the same direction, pointing towards the negative, pointing away from the positive. So all the three fields add, and they are in which direction? They're pointing in this. Remember, this is positive Z. They're pointing in negative Z direction. So the electric field should be in minus K cap. Which of the options have minus K cap in it and addition of all the three? Only D has minus K cap. So addition of all the three. Hence D is the right choice for 104 question. Now coming to 105th. There's an infinite line charge. Line charge trigger, it is electric field. Formula is E equal to 2K lambda by R. Now electric field given, distance 2 centimeters given, I need to find lambda. Given two parameters, find the missing third one. Here you have to be careful. You needn't calculate any of the powers since all of the options have the same power. Either it is 7.27, 7.98, 7.11 or 7.24. You need to be very careful with the numerical part. Substitute and get the answer. E equal to 2K lambda by R. Ignore the powers. Just consider the numerical parts. Okay, that is question number 105. 106 has been a hot favorite of examiners since age-old days because electric dipole in a non-uniform electric field will always experience a force and a torque. Hmm. So it is going to experience a torque and a force. That is absolutely right. 106 goes with C. Like we don't know whether it is in the direction of the field and things like that. It's going to experience a torque as well as it's going to experience a force. Cool. So this is about 106. It is a non-uniform electric field. So 106 goes with C. Now, question number 111. 111 question deals with equipotential surfaces and potential difference VA minus VB the same as VB minus VC, right? If T1 and T2 is a distance between the equipotential surfaces, we know that as I go away from the charge, farther electric field reduces. And what is electric field? Electric field is minus dV by dx, right? So electric field at this point is going to be is going to be greater than electric field at this point. When will that happen? dV is same for both points. For both points, dV is same. Why? VA minus VB is the same as VB minus VC. The delta V is same for both of them. If you notice, delta V is the same for both of them. Here and here, the delta V is same. dV is same. But how do I make field over there weak and the field nearer strong? Only with the help of thicknesses T1 and T2. So if only T2 is greater than T1, then field at 2 is going to be lesser than field at 1. Because I know as I go away from the charge, electric field should reduce. So field over here should be lesser than field over there. When will that happen? Only when the distances, dx's, adjust themselves appropriately because the dv's are the same. Right? So I can say that T2 should be greater than T1. Which of the options is T2 greater than T1? It is option C. The concept here being, if you want long story short, the concept here is being, if distance between equipotential surface is less, their electric field will be more. That's it. That is question number 111. Now, question number 119. Question number 119. Assertion reason type. Whenever charges are shared between two bodies, there occurs no loss of charge. Yes, I know that charge from this surface will travel through a wire and deposit here. Charges won't escape. So I can't deny this statement. However, there's a loss in electrical energy. True that. You know why? Because once the charge leaves a surface and touches the other one, the charge will experience a boom, collision, a collision on the walls of the conductor. Once the charge sticks to the wall of a conductor, it will dissipate heat energy. What kind of a collision is this? Where one entity sticks on the other entity, it is an inelastic collision. So whenever there is a charge redistribution, there is a loss in electrical energy. Therefore, statement 1 is right. What about statement 2? Electrostatic potential energy does not come under the purview of conservation law of energy. Well, it is nonsense. Any form of energy comes under the purview. It is not preview, it is purview. Purview, purview, which means the can we apply energy conservation if the energy is electrostatic potential energy? Yes, we can, but statement 2 is claiming that we cannot apply energy conservation if it is electrostatic potential energy. Therefore, statement 2 is wrong. Statement 1 is correct. Statement 2 is wrong. What about question number 120? What is not true? Trigger word, not true. Equipotential surface, okay, for uniform electric field cannot be spherical. Equipotential surface for a uniform electric field cannot be spherical. Why so? Because if electric field is uniform, at all points, equipotential surface should be perpendicular to it. Okay, so it should be a flat surface. If it is a spherical surface, electric field, if the equipotential surface is spherical, electric field will be having different directions. Then it is not a uniform electric field. The concept being used is electric field being perpendicular to equipotential surfaces. Here, electric field has the same direction throughout, therefore equipotential surface is flat. Here, electric field is different directions. Therefore, electric field is equipotential surface is spherical. But it is uniform electric field. Therefore, equipotential surface is spherical. That statement is not correct. Equipotential surface is flat. I won't even bother looking at C and D since B is not true. Therefore, it is a right choice for 120. Now going to 121. In 121, I need to rank the four regions according to the magnitude of X component of electric field. Given is V versus X. How do I relate E, V, and X? We know that E is minus dV by dx. Magnitude चाहिए, so I will use just dV by dx. What is dV by dx? dV by dx is the slope of Vx plot. slope of Vx plot? Well, look at the region over here. The slope is 0 because it is horizontal. So electric field at 1 is 0 in this region. At 3 is also it is 0. E3 is also 0. Which of the options says E3 and E1 both of them have the same electric field? Only B. So hence the right choice is B only. I won't even bother to evaluate the other options since E1 and E3 both are same. Now, question number 122. In question number 122, the work required to set up the four charge configuration into a square shape of side length A is right. Well, what is a work required? Work required will always be equal to the potential energy of the system. The funda is work done is equal to potential energy of the system. How to calculate potential energy? You make as many pairs as you can from this. So kq into minus q by a plus kq into minus q by a plus kq into minus q by a plus kq into minus q by a. Totally, there will be minus 4 times q square by a. The option should be in negatives, right? So I can eliminate D. Either it is A, B, or C. And then it is again even more. It is K minus Q into plus Q by root 2A plus K into plus Q into K into minus Q by root 2A plus K into plus Q into plus Q by root 2A. So it is plus 2KQ square by root 2A. So this is your potential energy of the system. Please keep note, minus Q into minus Q is plus Q squared. So that is where there's a minus sign over here, plus sign over there. So greater sign is negative, so the option should be negative, eliminate T. You put the values, you put root 2 goes with 2 as root 2. Okay, so it is take kq square by a common. You will get a minus 4 plus root 2. Root 2 value is 1.4 something around. So it should be 2.6, 2.7 around. So you see what you can make out of question 1, 2, 2. Now, question number 123. Right? Question number 123. Here we have drops. The drop wala question, it has been appearing in CET also. So the N drops case is with us. A very familiar question, even in KCET, we can say. N identical drops. The two central concepts behind such drops question is one is volume conservation, which means final volume should be equal to initial volume. The second one is charge conservation, right? And what does volume conservation mean? Initially, there are n identical drops. So n times volume of one drop, let the volume of the small drop be r. So the total volume is n into 4 by 3 pi r cube. That should be equal to volume of the one large drop, which is 4 by 3 pi r cube, where capital R is the radius of the one big drop. Small n drops equivalent to one big drop. So this is the radius of this is charge conservation. If each of these droplet has q charge, the total charge is going to be nq. So the total charge on this is nq because charge is conserved. Now, how do you relate these potential? Potentials we relate with the help of the concept of capacitance, which is Q equal to CV. We apply it for one drop at the first. For one drop, spherical drop, it is Q equal to 4 pi epsilon naught R into V1, where V1 is the potential of the individual drop. Here V1 is 10 volts. Now, uh, we apply the same equation for a big drop, which is NQ equal to 4 pi epsilon naught capital R into the voltage. Voltage let it be V2. So I have got these informations with me, and I also got this information with me. I cancel 4 by 3 pi, 4 by 3 pi. I get nr cube is equal to capital R cube, right? And here, from these two equations, I can divide the first with the second. When I divide the first with the second, I can cancel many things. Q and Q, 4 pi epsilon naught, 4 pi epsilon naught. So I have 1 by n equal to R by R into V1 by V2. V1 by V2 is given. V1 is 10, V2 is, I guess, 40. And R by R ratio, where will I get? R by R ratio is over here. So what I can do is R by R whole cube, I can write it as 1 by n. So R by R should be equal to 1 by n power 1 by 3. So R by R is 1 by n power 1 by 3. So I have the equation in n's. I have the equations in voltages V1 and V2 given. So from this, I can find the value of n. The value of n, if you can put in the numbers, it is C8. Now, question number 124. In 124, identify the wrong statement. Very tricky one. It involves electrical potential energy whenever two protons, proton electron, and two electrons. We remember this, right? Now, if the two protons are there, what would happen to potential energy between them if the distance between them is decreased? Okay. If the if I try to pull them closer, they both repel. Therefore, there I need to put some work in order to do that. That work will be stored as an increase in the potential energy, right? So therefore, the first statement is correct, but I want the wrong one. The same can be said about a system of two electrons, because even two electrons repel each other. So when I try to pull them closer, the potential energy increases. So even D is correct. So between B and C, our option should lie. What would happen if a plus and a minus charge proton electron system, I increase the separation between them? I pull them apart. To pull them apart, I need to do some work. Reason, they are opposite charges, they attract each other. So to pull them apart, I need to put in some work. Where will the work done go? The work will go in increasing the potential energy. So if I pull a plus and a minus charge apart, I will have an increase in potential energy. Therefore, if potential energy increases, separation should be increased. Separation increases, potential energy increase. So this statement is correct. So the only option which doesn't make sense is option B. It is wrong, but they want the wrong statement. So the right choice for the question is option B. If I decrease the if I decrease the separation between the charges, it is attracting anyway. So I need not put any extra work. So potential energy of the system is going to decrease. It's not going to increase. You can always take the analogy of a spring when when dealing with such questions, having the two ends either coming closer or going farther apart. If I want to stretch a spring, well, I need to put in some work. But how about already a stretched spring? I let the charges come back, so it is going to the potential energy is going to decrease. So and a helpful analogy is always a spring. Now the concept behind question number 125: capacitors given, distance given, potential difference given, released from rest given, what is its speed when it hits plate 2? Two things is possible. Either approach this kinematics way or approach this work per energy way. We will use work per energy. Initially, the electron is at rest. So initial kinetic energy is zero. I want to find the final kinetic energy. Why? Final kinetic energy will have information on the final speed. Uh, well, the increase in kinetic energy is equal to the decrease in potential energy. What is the potential energy that is decreased? Potential energy that has decreased is charge on the electron into the potential difference, which is 20, right? So this is a loss in potential energy that should be equal to gain in kinetic energy. I want to find V. Initial kinetic energy is anyway 0. So I want to find V. M of electron is known to me. Charge on electron is 1.6 into 10 power minus 19. So I get the value of V squared. I will take the square root and I will have the one of the right choices. So it becomes simple if you approach it using the work power energy way. The gain in kinetic energy is equal to loss in potential energy, Q into. Now going to question number 126. In question number 126, I need to find electric field at 2. Concept recheck. Given the plot of Vx, how will I find E? E is a slope of Vx at 2, around 2. I get to see that the line, the plot is horizontal, entirely parallel to x-axis. So slope becomes 0 over here. Therefore, electric field is 0 at the point x equal to 2. That is question number 126. Now, question number 127. It looks slightly, very long thing, but I guess you can do this with, going by basics. What is a basic concept? You have released an electron with u velocity parallel to a uniformly charged flat conducting plate. We know that due to a conducting plate, you see, uh, the field is always perpendicular to the sheet, right? So the force experienced by the electron is always going to be the opposite direction of the field. So electron is going to experience a downward force. So it is getting attracted. It strikes the plate after traveling a distance L along the direction. So this is it. That this distance is L. What is surface charge density of the conducting? Right. What is the vertical force experienced by the electron? It is a charge of electron into electric field. Electric field due to a conducting plate is simply sigma by epsilon naught. So the vertical force experienced by electron is E into sigma by epsilon naught. What is vertical acceleration? Vertical acceleration is going to be force by mass, which is E times sigma by m epsilon naught, where m is mass of the electron, right? Now, initial velocity, vertical velocity of the electron is 0. Okay. Now, it strikes the plate after is projected from a distance d. So the distance between this point and the plate is d. So y is 0. Acceleration I know the distance traveled is d. So how will I relate d, a and u? Our good old formula is equal to ut plus half at square, where u is 0. So half avt square. From here, I get to know the time taken by the electron to hit the plate, right? During this course, the horizontal component of velocity of the electron will never change. Reason is there is no horizontal force acting on the electron, right? So what is going to be the horizontal displacement? Horizontal displacement is equal to the horizontal speed u into time taken by the electron to reach the plate. The time taken is given from this equation, root of 2d by a, where a is av, vertical acceleration of it. So L is equal to U into root of 2D by AV, where AV ka value I will put over here, U ka value I know. From this, I can definitely get the value of sigma, because sigma is the only unknown quantity. So that is the solution for 127. It is just like projectile motion. The horizontal component of velocity is not going to change. Initial vertical component is zero. So instead of acceleration due to gravity, you have acceleration due to the electric field. We ignore gravity over here. So that was question number 127. Why can I use half AVT square? Because we know electric field due to a plate is always a constant. It is not variable. So the acceleration is a constant. For all constant acceleration cases, I can use S equal to ut plus half AVT square. So now going on to question number 128. In question 128, there are two metal pieces. In between them, there is 800 volt ka potential difference, and the distance between the plate is 0.02 meters. A particle of mass m is suspended in equilibrium between the plates. Mass m is given. I need to find the charge on the particle. This has some charge. It is in equilibrium. It is hanging in between the plates. When can it hang between the plates? When its gravity force is matched up by electrostatic force. But I don't know the electrostatic force. How to relate electrostatic force with voltage, potential difference, and the distance? Easy. E equal to V by D. E equal to V by D. V is given, D is given. So I can find E with the help of E. I can equate Q E equal to mg. E I very well know. M is given, G is known. You can find the value of Q. What is the charge on the on that mass? There's a trick. Whatever you get here, it will be in coulombs. We know elementary charge is equal to 1.6 into 10 power minus 19 coulombs. So let us say you have got some x coulombs as the answer. This equal to x coulombs as the answer. So this equal to how many elementary charges? That is a final nail in the answer, right? So first I will find the charge in coulombs. Then I use the relation. Elementary charge is 1.6 to 10 power minus 19 coulombs. Then x coulombs will be how many elementary charges? That is question number 128 for you. Question number 129. Equipotential surface is asked, direction and magnitude is asked. Well, we know that a relation between field and equipotential is E equal to minus dV by dx. Hold on. Where um, we know that electric field is always perpendicular to equipotential surface. So magnitude of electric field shall be taken care of this dV by dx, whereas direction is from the property, electric field being perpendicular to equipotential surface. So how can I get direction here? If this is equipotential surface, electric field has to make an angle of 90° with the surface, right? If it is making 90° with the surface, what will it make with the x-axis? Theta is 30°. I can examine the triangle. This is 90, this is 30. So by angles in a triangle, this is 90, this is 30, this has to be 60. If this angle is 60, this oblique angle should be 120 degrees. So the electric field should make an angle of 120 degrees with the x-axis. Fine, direction part is known. How to find the magnitude? Magnitude is E equal to minus dV by dx. Well, here is the trick. Here, dx should not be misunderstood as the distance between the uh, equipotential surface. Dx is always, concept check, it is the perpendicular distance between equipotential surfaces. Golden point. Most misunderstood point in NCERT, they have mentioned in a very small place. You can make a note of this. Electric field involves that distance, which is a perpendicular distance between equipotential surfaces. So, how to find out perpendicular distance between these two surfaces? I will simply draw one perpendicular 90. This is at 10. This is at 20. X coordinate. What's the distance between them then? 20 minus 10, so this is 10. This is 10. This angle is 30. I need to find this side. Trigonometry wise, if I write a triangle like this is 10, all right. This angle is 30, all right. What should be this? Perpendicular, this is a perpendicular. Perpendicular by hypotenuse, P by 10 is sine of this angle. Sine of this angle is half. So perpendicular should be, say, 5, right? So the perpendicular distance is 5. So the Tx value or the perpendicular distance between them is 5. Okay. So that is the trick over here. E equal to minus dv by dx. So it should have a 2, not a 100. It should have a 2 somewhere around it. So and this is in centimeters, mind you. Biggest catch, centimeters. So when you take this distance, it is 5 centimeters, right? The voltage difference is 30 minus 20, which is 10. 10 by 5 to 2 by centimeters, 10 power minus 2. So 10 power minus 2 goes to the numerator, 200 volt per meter, making an angle of 120 degree with the x-axis. Beautiful, isn't it? Not a neat level, but it has a lot of catches. I can easily say this is of a mains level. E equal to minus dv by dx, direction always perpendicular to equipotential surface. So that is question number 129. Now, question number 130. An electron and a proton mark the correct statement is there. Outrightly, I can tell that two equipotentials may intersect is incorrect. Equipotential surfaces cannot intersect. No work is done in taking a positive charge from one point to another inside a negatively charged metallic sphere. Correct. Because inside a conductor, potential is constant, equipotential surface. So no work is done. An electron and a proton were released from rest in a uniform electric field experience the same force and the same acceleration? No. A equal to QE by M. They may experience the same force, QE, but mass of electron and proton are different. So they experience different acceleration. Therefore, the statement A is incorrect. So the only correct statement I can say is option D, where no work is done in taking a positive charge from one point to another point because the entire surface is equipotential surface. Now, question number 131. Well, what is electric potential and energy density? Right? Energy density is always given by half epsilon naught E square NCRT ka line. And V, they're asking the plot between V and U. Cool. So V is, we know, KQ by R. What is U? U is half epsilon naught E square. E is KQ by R square whole square. And they're asking V power 4. So I will put V power 4 also. So this would be entirely V power 4. So KQ power 4 by R power 4. So V power 4 also depends on 1 by R power 4. U also depends on 1 by R square the whole square, or U also depends on 1 by R power 4. So both U and V power 4 depends on 1 by R power 4. I can say that V power 4 is directly proportional to U. This is nothing but, this is plotted on Y, this is plotted on X, Y proportional to X, straight line. So these two are eliminated. Is it positive slope or negative slope? Well, it should be positive because both potential and energy density, as I increase the value of R, they decrease. So both V and U go hand in hand. Therefore, they are directly proportional. The correct option is B. Lot of formula dependence over here. Now, question number 132. We can use Gauss law only when C E dot dA is Q enclosed by epsilon naught. I can use this form only when only when electric field is Electric field is a magnitude of electric field is constant. I can pull out electric field outside the integral only if electric field is constant. Not only that, the direction of electric field should always be perpendicular to the surface whatever I am taking. That is possible only when the surface is equipotential, because we know field and electric field is always perpendicular to equipotential surface. So what are the two conditions in which I can use this condition? When same magnitude is there for electric field all over the surface. Not only that, the uh, uh, the direction of electric field should be perpendicular to that particular Gaussian surface, which is just like an equipotential surface. So I can say when the Gaussian surface is an equipotential surface and magnitude is constant all over the surface. So 132 goes with C, not for anything else, remember. Now going to question number 133, right? The core concept for a grounded conducting sphere, whatever it is that the potential, the potential of this, whatever is connected to the ground, is zero. So what can I say? I can let the final charge on this sphere be q dash. The total potential at the center will be kq dash by r plus potential due to this q at the center, which is kq by d. The sum of these two potentials should be zero. Why? Because that is the total potential. Superposition principle. If the charge q dash is there on the sphere, potential due to q dash is kq dash by r. Potential due to q is kq by d. Sum of those two equal to zero. Now you get a relation between q dash and q, and that is your option. So how to make this question easy? We can make this question easy by thinking of what will happen if d tends to infinity. If d tends to infinity, the charge will go very, very backwards. This charge will literally have no effect on this. So the charge induced will be zero. So the charge which flew to the earth will also be zero. So the charge will be zero if d is infinity. Which of the options satisfies that? This doesn't, this doesn't. Either it is A or it is C. Okay. So is it D minus R or is it only D? Obviously, it is only D from this relation. You look at the relation there, it doesn't involve D minus R anywhere. So the right option is option C. Now, question number 134. A point charge Q is placed at a distance of r from the center of a conducting shell of inner radius 2r. That means it is placed somewhere over here, and outer radius is 3r. The point charge q is inside the distance. What is the electric potential at the center of the shell? Interesting question. Electric field potential at the center of the shell. Well, due to this q, which is, placed inside, since charge on a conductor should be effectively zero, it will induce some charges, negative charges over there. So that is equal to minus q. If charge here is minus q, then correspondingly you will have induced plus charges outside appearing. If it is plus charge over here, again corresponding minus at the inner surface and correspondingly plus at the outer surface. Total potential at this point is sum of potential due to this charge Q, the inner charge, negative charge, that one, the outer plus, the inner negative, and the outer plus. So there are so many terms. Okay. So, well, that is a task. So we use superposition principle to arrive at the answer of question number 134. Wow. What are the core concepts for question number 135? It is similar, very similar to Rutherford's scattering experiment. Gold foil, alpha particles from infinity. This distance is zero point 0.5. What should be the minimum V naught such that the particle just grazes the shell? It means it comes like this. Yes, just grazes the shell. So the final velocity over here, V, should be perpendicular to the sphere. That is the condition. So what are the various aspects? Let the speed at which it grazes be V. Many things are involved here. The first thing is angular momentum conservation. Wherever this just grazing condition appears, perpendicular condition appears, their angular momentum is conserved. What is the initial angular momentum? Mass of this particle, speed of the particle V naught into perpendicular distance. So initial perpendicular distance was this, which is given as 0.5 mm. That should be equal to final angular momentum m. This v into this perpendicular distance now is r. Angular momentum conservation. Now what would be other conservation condition? Of course, energy conservation. Initially it was half mv naught square kinetic energy. Now when it is at this point, it is potential energy, which is K Q1 Q2 by R, where R is this 1 mm potential, plus here also there is some kinetic energy, half mv square. So we have two golden conservation laws, angular momentum and energy conservation. So how do we guess it is angular momentum? It is just by that condition, just grazes the shell. Grazing means it has to do with directions. Wherever directions comes into the picture, their angular momentum conservation appears. Is there anything more from the question I can extract? No. So that is it. Initial kinetic energy is equal to final potential plus final kinetic, and initial angular momentum is equal to final angular momentum. So I have two equations and a single uh, uh, unknown. So I can actually find V naught. Okay, I can either find from angular momentum conservation, or either or I can find from energy conservation, right? Uh, the charge is shown. Whatever the particle charge is, the same charge is there on the sphere, same charge. So Q1 and Q2 both are same, which is Q, right? So this is about either use energy conservation, angular momentum conservation from wherever you see a minimum speed, that would be the answer. Get the value of V naught. Okay. From here, right? There are two unknowns, V and V is an unknown, V naught is an unknown, two equations, two unknowns. Eliminate and find the value of just V naught. Eliminate V from a system of equations. So this has been an attempt to enhance your conceptual understanding of some of the very tricky questions on the NEET test 2. So do physics and get the fundas of each problem very clear. Thank you. Take care. All the best.